Back to that Milton drawing. So, to recap what I was doing earlier before lunch, I was thinking about the way I want to structure the logic for having this sort of more complex flow where a combat round begins and a decision gets made about whether to just fight it out or whether one side or both sides are going to try to run away. And there's an idea for a new sort of game that happens here. There's, combat is a pair, each side picks some combat moves and then they get resolved. And that's what I've always done. Is it's just started here. There's really nothing special about round begin. It's really just combat moves, resolve, loop. That's what I've been doing, right? And this new thing has this way where if one side flees and the other side fights, then instead of ending up here at combat moves, the logic is they end up here at these chase moves, and this has to this has a certain dependency. Flee moves get chosen first, so they're no longer parallel. These can impact what is seen as options and also what information is available here. So the question then becomes, and then the next piece of this picture is there's a green dot and a purple dot. Hopefully they're distinguishable for everybody pretty easily. Green, 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 and purple, 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 right? And the idea is the green dot is one of the parties, the purple dot is the other party. And so before, they would both be here on this state together. Well, technically, they would just be on this state. They'd make some moves. A resolve would happen. And then we'd repeat or we'd exit, right? That was what was happening. The new system allows for more possible flows, including one party fights and the other party flees, and now these dots flow separately. So what I need to do is think through what is and isn't useful about structuring things this way. Is this something I can... Is this a data structure I could use to lay out the code itself, to phrase the code, we should say, so that it actually makes sense and is convenient and it's possible to work with it. And on top of it, is it possible to work with it? Does it lead to usually landing inside the logic that I want? Is this the right building block, or is this just a special case building block for this one flow? In order to answer that, I'd have to go even farther and design yet another integrated flow into this a chart like this. But in the meantime, I want to try to sketch out a few things about how I would represent movement through this flowchart as a data structure. And I know that there are multiple points flowing through the chart. Okay. Now, the way I coded the chart is these hexagon shapes represent actual states where player choices are happening. And the ovals represent some kind of automated processing, whether it's a simple check, like checking what kind of flow the other party went through. That's what the did enemy questions mean. Or more complex processing, like the resolve for the combat game or the resolve for the fleet game. So these are computations that lead to a result based on the data that's available. They are where things like rules get enforced. These are states where moves are made by players. This is where brain scripts run and where eventually a human interface might be inserted, right? Now, what I need to do is just grapple with the part of the data structure that's these states. Right, and I think that there's two pieces. One, there's the data structure for representing a current state with this, which is a current state. why don't we write this over here? In this model. All right. Penmanship. We're working on penmanship today too. Here we go. Let's do this. In this model, how is the state represented? So the state is a set of parties that are flowing through the system paired up with which state node they are in the flowchart. Not sure how to be saying party. Yeah, I think it's party. Well, let me rename that. So we're now talking about this more generically. I'm just going to call each of them an entity. They could also be like execution fronts or players or something like that. So it looks like this. Which basically means we're looking at something like a list of entities and state nodes, although, yeah, okay. But it's actually not that. It's a map. So it's more like we have some subset of the entities. So there's like entity count will be a number, a count, and then the states are actually a map from the indexes of entity count to the values of a state node. Right. So that is to say, it's not a list because you don't get one for each entity. Now, this whole thing about fight or flee is cool, but we made this picture by representing what happens from a single party perspective, and then we have to ask questions about the other party and make them sync up to actually make sense. There's a logical way to write this that wouldn't make any sense, where, for instance, if I were to say that, you know, if you hear you fight and the enemy also fight, yes, then we go into chase moves and depend on flee moves. But at the same time, the other party also went into the fight, right? You could write an invalid diagram here. Just because you put down the names on the arrows and link things up the way I did here doesn't mean it's guaranteed to be valid. The only reason this is valid is because it works out that whenever the green party or whenever one party goes this way and the other party goes this way, or whenever one party goes this way, the other one's always going this way, right? That's actually baked in. And so you're not free to connect these up any way you want. They have to make a certain kind of sense. And it might be good to think of a data structure other than a flowchart here, because if I just do states where decisions get made, so player decisions interleaved with resolve logic, the problem is that there's no guarantee that the resolve logic always takes you to coherent states where interconnections between the states like this will be able to be accounted for, right? And there could easily be inconsistencies in the flow where one party ends up in combat while the other is fleeing, which is not a game we even have a resolve for, right? For the combat resolve here is actually a function that takes in two combat moves. The flee resolve takes in a set of flee moves and a set of chase moves. So these resolves do depend on consistency of the flows according to a higher level logic than what's actually represented in the flow chart. And so it's a little hard to see how I would wrap my head around what's allowed and what's not allowed with this picture. So I want to shift the data structure. I think it might work out a lot better if I come up with a picture that does not have a single party perspective but a global perspective, or rather not even a global perspective, but rather accounts for the multiple parties and the various paths that come out of each combination of decisions. And I think the right tool for that is a game theory model. So let's redraw this as a game theory chart instead of a flow chart, and I can show you how I think it could be done. So here's the game theory version. Is that good penmanship? I think we can do a little better. Hold on, let me try again. Okay. I think that's good. So here's the game theory chart version. There's still like an idea of a player state, so I'll still have, or like a player decision node. So we have round begin. Now the game theory charts look like this, right? They're like a big, kind of a Punnett square shaped thing. Right, we have fight. Here, I will use colors now because we are dealing with two different players. Player 2 gets fight. and flee along the top. Player 1 gets fight and flee along the sides. Combat moves. So the payoff matrix, instead of containing numbers, contains transition states. That's fight, fight. If we do fight, flee, then we're going to get chase moves. You know what, I'm going to add the green and purple dots. Green dot, purple dot. Combat moves. And then there's combat moves. No, not combat moves, it's chase moves. And flee moves. With a kind of time dependency that exists here, and purple there, green there. Green and purple. That second one got a little smooshed in there, but okay. And this one, I'm gonna just put little quotes in because it is symmetrical. So this and this would just be mirror images of each other, right? The purple dot would get the chase moves, and the green dot would get the flee moves, with the arrow going the other way. Well, still from chase moves to flee moves, but from purple to green. Okay, so then combat moves, combat moves. Is this thing. Here's what we do if we have combat moves. That is implemented by like a combat resolve logic. Which can flow to another combat round, or it can lead to being done So there's combat moves, and then there's the flee moves, chase moves version, which is like, oops. With this arrow on this, which then go into a chase resolve, or flee resolve, I think I called it. So I guess these are not very, I mean, the logic for resolving these is still simultaneous in a sense, or what's the word I'm looking for? The this could in theory be a table, but it wouldn't just be two. It'd be one for every possible combination of moves in the game, and then reduced down to the information possible for a specific set of characters, right? Which just leads to one, I can't draw one because it's different. The table itself changes depending on the state of the tiles and the entities. Um, so really, this is just a very lightweight resolve, right? The decisions that get made during round begin are like the decisions in these ones, but the move is just either you fight or flee right now, right? And this is the I don't know, like this is a little resolve. Whoops, penmanship. Let's try again. This is a little resolve. Right? So then the structure of each of these is something like a state, and an entity 1, an entity 2, we'll just say that each state and it comes with a list of entities. Or let's say Well, okay, here's the thing. I could basically boil this down to a different picture. What I'm trying to say is there's an alternative picture that is similar, but instead of using the flee moves, chase moves, that was maybe an artifact of drawing this as a flowchart from a single perspective. But what's actually happening here is that this is a state, these two together are a state, and this is a state. Um, well, this isn't true. These two together aren't a state. It's also possible for both to end up with flee moves. I oversimplified here. Oops, you stop. Can I make my eraser bigger? Okay. This is actually flee moves for both. And that is part of why having the flowchart is helpful. But now, drawing it this way, we can see that the other kind of resolve that I skipped is a resolve for flee flee. And the reason we collect these is because there's a consequence to putting in the effort to flee in terms of the expenditure of resources that you commit to when you don't even know if the other player is doing it or not. So we're basically saying you have to get your charts down to some final states. These then that I skipped are actually important if we're going to say that, right? Either you're going to write a complex resolve or a simple one, but whatever the case is, you have to always end the resolve with an updated state. So a combat resolve can lead to a state of exit and KO. And then the fleet resolve can result in an exit exit. Or maybe even an exit KO. I'm not going to rule out the possibility that during the chase there is still damage happening one or both ways. Right? So this will be able to go to any of those states. This always leads to an exit exit state. Okay. Now, I haven't defined what happens during some of these patterns, but part of the point is that the resolve of that might be owned by something else. Like the fact that we entered into this state, at some point we want to be able to say, okay, the entirety of the combat system front round is that I guess this needs to be called combat round actually. And also it needs to be more carefully written. The penmanship is no good on the second word here. Okay, let's see if we can do this. Combat round. It's kind of small now. Combat moves. So anywhere where I'm just writing one state, that's a shorthand for sending both of them through. This whole way through, we're assuming exactly two entities are flowing through. And what I'm seeing that's most relevant here is that here, this is going to be something I just want to be able to script up easily, like a symmetric and maybe also separately an asymmetric payoff matrix for a finite set of pre-known moves. But I also need to be able to code in arbitrary resolves. And I kind of want to be able to say that for any of these resolves, I want the possible output states to be something I can know. And I think that there's easy theorem here that I can apply, which is that if the initial game is symmetric, then the whole game is symmetric. At least in the following sense, right? Obviously, the parties might have different characters or different abilities attached, but when we look at just the concept of this party flowing through these states, and we forget those that there's additional state underneath at just the level of the state diagrams and the way that they get resolved. What's sort of happening is I have a set of state nodes: combat round, combat moves, flee moves, chase moves, and then some of these are possible. So this is, if I were to spell this out, this is a combat round. So they're both at the beginning of a combat round together. This is symmetrical. So then, because it's symmetrical, anything state that I can reach with party 1 playing one role and party 2 playing another role, I can reach it the other way too. So here we've got combat moves. Combat moves, this is the only way that combat moves get in play. There's not combat moves in a different state in the system right now. Then there's flee moves and chase moves. And so this can happen either way because of the fact that this is symmetrical. And then we have flee moves, and so again, this is symmetrical just by the fact that the structure of the minigame itself is symmetrical. But you can see that no matter what happens, if the first move is symmetrical, then all the ways that you can flow through the system should be equally possible from that point forward, both ways, right? Either combination of parties could, or the parties could swap positions in any of the states. So really, the reason I'm belaboring the point is to say that this is not like half of the picture. It's not like we need to think of this as two different states, one with the green and the purple here and here, and one with the purple and green here and here, right? Like, I don't need to think of that as two separate things because of the symmetry of green and purple to begin with. But if I didn't have that, then I think it is conceivable. Well, still, if it's reachable at all, the logic should work. And then I guess what I'm saying is that for each of these patterns of states that I want to support, well, here's why I'm thinking about that. What I'm thinking about is for each pattern of states that I want to support, there's a resolve for it. There's a code path for that state. The individual hexagons entail a specific set of choices to a specific party. So one hexagon, okay, so that means these shouldn't be hexagons, first of all. These things that are not internally known don't need to look the same. They're more like signaling an end state, and so they don't have a built-in logic. What's a good symbol? I could put them inside of boxes. I could double bracket them. So this would be an exit KO state. This is an exit state. Both parties get to exit. This is an exit KO state. And then this is an exit state. So I think basically what we're saying is this whole thing is like a flowchart where it's initially going to be right here with both. It's going to be at combat round is the initial state. Two parties dropped in at a starting point that is symmetrical. Then they play out a game which updates their state, and that state then brings up a new game. And here the game is choose to fight or flee, and here the game is choose combat moves, which is a much more complicated choice. Here the game is one party is choosing flee moves, the other one's choosing chase moves. Here the state is they're both choosing flee moves. Then once all the moves are selected in any of these cases, a resolve happens, which updates the state. So then the idea is these are basically like, just like here we have a discrete table, fight and flee, exit and KO. There's also a possibility, I guess, I didn't add it in here. There's also always the possibility of a KO ending. Right. Now the tricky thing is, for all this whole idea to work, the the potential transitions of states need to be something I know about, right? I kind of need to know that this is everything I need, right? I need some kind of, or at least I'm thinking about getting some help with that. Maybe I don't need help, but the data structure we have so far is a list of state nodes in a particular order, or rather, yeah, let's just say in a particular order. It's good enough that way, right? I don't think I would ever want, maybe I do just want the set, the count of each one. So 2 combat rounds, 2 combat moves, 2 flee moves, 1 flee move, 1 chase move. For like indexing for keying the resolve functions. But you can imagine all it takes to place a combat system now inside of a larger context is to say, take the exit and KO end states and make a new, game theory chart for those two outcomes and all the way, like all the follow-up states for the game, right? The overarching game. So if you beat the enemy, you play out the thing where you get the reward and move on to whatever the larger context says comes next. If you get KO'd, you're down one way or the other. And if you both left, maybe you don't get the reward for beating the enemy. Maybe something advances, right? There's some other kind of handler for letting the enemy escape under special circumstances, or they get re-entered into the deck to be drawn again later as an encounter in the same area, or whatever the extra logic is that you would want. So the cool thing about doing it this way is that, unlike here, I can very easily see how I would verify that it all makes sense. You would look through the list of all possible exit states. So here we have 3 possible exit states written down. Since it's a symmetric board game theory chart, this payoff square has the same state as this one. So there are 3 specified here. There are 3 specified here. There are 4 specified here and 1 specified here. And so then you can look at each of these 1, 2, 3, 4. That goes there, there. 1, 2. Yeah, and then there are 3 possible exit states. 1, 2, 3, and then this, and this are also exit states that are repeated. But internally, we have a handler for. We want to check that internally we have a handler for everything. We don't check for handlers on these exit states, right? These terminal states. We don't check for handlers, because that'd be like checking that somebody handles what you return or something. That's up to somebody else to decide if they care and how they care. You just get the job done of returning it. But the internal system has the ability now to verify that these 3 exist here, here, and here, and that this one exists here, so that the whole thing is specified. So I think this is clear in my head. Let me see what it would look like if I were going to do that in code. I'm just kind of sketching out ideas right here. Alright, if we do chase moves, flee moves, then the resolve is, you know, it's a function like it's like okay, so there is something important here, which is that there's a timing component between these two that is not the same as here and here. And it's not good enough to just hope the resolve can encode that, because I'm bundling in the concept of getting these moves from these states themselves. So when I create this, I need to encode the dependency right here, right? It's not good enough otherwise. Now that's easy enough as long as there are just going to be two. To include that dependency information. What that basically means is that this comes in time downstream of this decision getting locked in. Like, information about what happened here is visible here. And so the question is, how do we decide what's going to be visible, right, at any step of the way? It isn't saying here, when I make combat round, that's cool, but do I know who I'm fighting or not? When does that get decided? I can't just assume that when I pick this initial state and get a fight or flee, I know that I'll have the information about what moves to make, or what sort of moves I can gather from each player. But I think what we need to do are these states, or are these like move sets or something? Right, so these resolves aren't actually just about the resolution. The resolve is just about the resolution of the decision, right? So that's why this is weird. This is just some code that decides when to, like, where to transition next. So if I look at, let's look at combat moves first. And the logic is, at the end, if there's going to be, I mean, first of all, there's like combat moves resolve logic happens, and then there's a final step here that's like if party1 dot count and is greater than 0 and party2 dot count is greater than 0. Then we move to go to the state combat round. If party1.count is greater than 0 and party2.count is equal to 0, go to exit KO. Party1 equals count and party2 is greater than 0. Go to KO exit. And finally we go to KO KO when they're both 0. So that's how we resolve it, but that's not how we present it, right? There's also this like presentation of combat moves, which is about what information we deliver to each player before we gather the results. So it's something that we show the full state to party1 and party2. And then we choose moves for party1 and for party2. And there we go. But if we wanted to talk about how we present chase moves, flee moves, the answer is we show the state to party2. We let party2 choose their flee moves. Then we show the state to party1 and let them choose their moves. And so it's not really encoded here because it can't be, because we don't really know. This isn't enough information. The fact of the timing dependency here isn't enough information to do the right thing. You also need to know what to show and how much to show. And so here, there's an entire world of missing information about how we're going to regulate who sees what all the time. And that's a part of what's interesting about this. But it's clear that what this party sees here is going to include this. So for now, I'm just relying on the idea of like a single global mutable state that is not in any way segmented. And so when this chooses moves, it's not even like just choose moves. It's almost like well, what if I just didn't think of these as resolves, but I thought of these as states? shuffle and run moves. That's just going to be a shorthand for all the code that actually goes into implementing combat moves. But then I think there's got to be a thing here that's like clear moves, choose moves player 1 or party 1, choose moves party 2, shuffle and run the moves, and then resolves. Here the logic is something like clear the moves, choose moves for party 2, shuffle and run moves, clear the moves again, choose moves for party 1, shuffle and run the moves, and then if party 1.speed is greater than party 2.speed, then you go to combat round. If party 1.speed is less than party 2.speed, go to, well, this is actually go to combat moves now that I think about it. If they catch up, then you have to fight. And this is wrong. It should say that if we if we get this far, we might actually like to say sometimes this will go to combat moves. For both parties, and sometimes it'll go to combat round. And sometimes it'll do those other more rare exit scenarios, like they both here's if the runner gets away, and then these are if someone gets killed, which could happen, although it should be a more rare outcome for these. So if party 1 speed is too big, they chase and catch up, and so you end up in combat moves. If party 2 speed is big enough, then that's just the end of combat. Both parties exit combat like this. And if they're both getting the same speed, then you go to another combat round where you can decide to flee again, and you can also choose to stop running, and you can choose to stop chasing, and so on and so on. Now, I also want somehow to set up like a modifier here that's like gonna temporarily make this resolve a little differently. But this is all the common stuff. It's also totally possible that we'll get, and that's all if both parties are sail around. Otherwise, the same old resolve logic from before can go again here. All right, I'm gonna go take a quick break. Okay. So, as I was wrapping this up earlier, just to recap where I was at, I'm not really sure what to call each of these things. I'm calling this a state, but it's or a move set. It's kind of more like the state of a single point, and then these states are states for pairs of points. But the point is, I want to associate okay, so a way I could picture this is call these states. We might drop this information and just think of them as states. We might call this not a state, but like a rule or something. And so the rule tells you what you do when you're in that state. And boom, right? You pick your moves and then you stick a handler on each one. Now you see between these two rules, I'm staring at these because of the fact that these look so similar, right? What's basically happening is there's a handler for what happens when both parties are still alive. And that's different for each of these. But then there's the handlers that deal with one or both parties being gone, and those are the same. Because then these would look something like this. This would be, instead of saying all of this in both places, there'd be something like combat KO check or whatever would go here, and then this would come after that. Combat KO check goes here. These get removed, and but yeah, this basically is the idea. Combat round, you can transition to combat moves, flee moves, and then we need a rule for flee moves, flee moves. We get moves from both parties now. What if I wasn't putting moves over here though? Combat round is a state, and then you can choose fight or flee. So here, combat moves on each of those means we want to do +1 action, +1 quick action. Okay, I think the system makes sense. It's a big change from what I've already got. So it's going to take more time to get there than I anticipated if I actually want to build this correctly, but I think this is the right way to do it. Young Lane, what we have on the left isn't C code, it's just sketching. I'm just sketching out ideas. It's pseudocode. You can't go to on a parenthesis with the strings like this in C. What we have on the right is just plain old C code with not that much macros. But yeah, I'm trying to figure out the main structure of this concept, and essentially I think that a state is just an ID, and that these handlers I've been writing for a state are the wrong idea. I actually need rules that apply to a pair of parties who each have their own state. don't think I need any information on these tiles. I think what has to happen is, this is going to take a little while. I also think that the idea that Chase was separate is not going to work out entirely, but yeah, coming up with the transition path here is going to be hard. It's an interesting system, but let me write some more serious pseudocode for what this would be for a bit. All right, somehow you'd have to still have a combat context, I guess. Not sure where and how that's going to work, but I'll get around to it as I sketch this out. I'm going to give the moves. Calculate a move set. We're not going to add that. Oh wait, no, this is fight that I'm writing. Okay, this part I'm going to change a little bit. RPG state exit. Okay. So here, if both parties are dead, then we go to that state. And if they're both still alive, you go to combat on both. I don't really believe I understand how the combat context is going to work out. But we'll see. Now I'm gonna keep naming it this way. I think it makes more sense. And I do in fact need to revisit all of that to make it work, because what I'm missing is right here I don't have a way to add a move. So now the question is, do I want to Hi Maria, welcome. I'm doing pretty good. How are you? So I'm setting up a move for each party, and then here, what's next? We need to decide. Players make their moves. Right, so then we want to be able to see which state we're in, which is going to be like this. So we need the players make their moves, and their moves involve setting flee. So this will have a if RPG event context RPG event, this is used. Then let's see, we got to get the combat context. Sorry, that's not how you do it. You get the combat context this way. Then you go now you got to figure out which index this is, which means you have to go get this party if, let's see, do index equals 0, if party equals combat context parties 1, then index equals 1. That goes in the flee tile. This one will just do nothing, but it'll be usable. Okay, here's where we have kind of a payoff matrix situation. So if not flee and not flee, then we RPG go to contact context parties 0, state fight, fight. If you fled and you did not, then we get party 0 flee, party 1 chase. If we flip it around, then party 0 chase, party 1 flee. And if both of them flee, I'm going to go to this state. I'll run the old version of the RPG simulator for you so I can show you a little bit about what it looked like before I started the rewrite. Now that all is good, but that only applies if we aren't in, no, that's always how it works, right? It's one of those four, so that's the transition table for fight or flee. The tile script, the tiles here are the moves. So that's how it works. To do There we go. Simulation just finished. So what the simulation does is it creates these little characters like any RPG game would have, and equips them with bot brains and runs them against sequences of combat encounters. The enemies also having bot brains, so it's all simple bot brains running against each other, but with different combinations of abilities in each party. We get different statistical outputs here. So these are the diagrams showing us how deadly a particular sequence of encounters was. What happens with one of these is each of these lines represents a set of encounters that can happen, and they get shuffled together into a random order for one run, and then our party goes against them in that order. And we can see the difference between how well they're performing when they've got this blend of abilities versus how well they're performing when they've got this blend of abilities, or when they don't have any abilities at all. So the idea of the simulator is that you can see the relative strengths of various game mechanics against each other. As you're iterating on them and designing them and playing with them and stuff. So if both parties, if we go into the fight state, oh, hold on a sec. I've got a few minutes left here. This is all just a day of sketching things out, so that's fine that I didn't make any progress. Let me make sure the new RPG simulator still builds and runs. It does. That's good. So this part I think we will be able to come up with some kind of improvement on. If I didn't have to use the array here and stuff, if I could just build a transition table directly and then utilize it, how would that look? It would be something like I want to be able to say something like RPG tile proto party 1 move and party 2 move, and this would just be like, or maybe this would be like party moves 2 boom boom boom, and then you go party move I equals RPG move from party, something like this. Context, combat context, parties I, RPG um, I'm not quite sure how I want this to look yet. There's so many unknowns. I'm looking for some way to arrive at basically being able to write. Let me just write the absolute most magical thing. It would be like RPG tile fight, RPG tile fight. Maps to RPG state fight, RPG state fight. Maps to chase, flee, whoops, and flee and flee. That's what I hope I would be able to write, something like that somewhere. What if it was like this? Right, something like this might be the kind of thing. Yeah, I'm not sure. This is going to take a lot more than what I can do today. I think we're going to need I'm going to need a little more time to just fiddle around with ideas before I will decide where I want to move on, because this is a huge step in a different direction that is kind of the correct next step for the RPG simulator. But since that simulator project is still placed in the larger goal of being able to get the base layer tested for DLL stuff, getting all of this right before the transition to that isn't really helpful. On the other hand, transitioning to that before I get this right is gonna sink this iteration of the RPG simulator. So I'm gonna need to pick an area where I can. I think I need to get a little smart about the transition path here from what I had to what I'm looking for. There's a couple of missing steps along the way, but I'm starting to see how like a lot of this just comes down to finding the right language pieces for rapidly collapsing these uh, the management of these flows through states, and I just need more time to fiddle with that. I also need things like the distinction between generic moves where it's a combat system and like scripted decisions that are like binary fight or flee decisions. I haven't fully worked out how that'll get presented. I have to figure out how the brain system is going to adapt. I think now what's going to happen is the brain system is going to run off of the state that you're in, right? So each party is in a state. The party will know which state it's in. It won't necessarily know which rule is being applied when it knows what state it's in, and I think that's a part of the key. Um, there's the amount that's shown, and then there's the amount that's the full truth is a superset of that. Like if I'm in combat, I must know that I'm at this stage, but if I'm in a flee state, right? There's like no, there's a couple different rules that might be applied there. Maria, to answer your question before I go, yeah, I have plans to go way beyond combat. So this is, right now I'm just doing combat because it was a cool place to start. But I want to have simulations for, I mean, the simulation already has a basic idea of resting while you're traveling. So the player party gets a certain number of chances to refresh their abilities, which are called their rests. And then beyond that, I'd like to be able to, during those intermittent periods between combat and during rest, have additional skills or character abilities and stuff that can go off then and that can run other mini games. I'm currently working on extending combat's mini game to include the concept of a chase sequence. I want to be able to map out lots of different little RPG mini stories onto a turn-based engine. So, yes, gambling, shopping, bartering. Um, there are a number of simulations besides combat and this new combat chase sequence thing that I'm doing that I want. In fact, there's probably going to be even more. At some point, I probably want to have the mini game for um, deciding what you do during travel, between encounters that stop you, what you, and as things go on, there might be other mini games to throw in, like being on. Yeah, I don't really track traveling supplies right now. That's not in the simulation. It could be. I have the old simulation had a concept of inventory, and the medic character had like a special ability that they could only use if they had a first aid kit in their inventory. So I was playing with it that way, and I had the idea of a healing potion, which gives you the characters more moves that they can use. I didn't have like rations and tent making supplies in the inventory as a part of the or camp making supplies as a part of the simulation. That was just built in. Like there's no variability to the outcome of the simulation is implied by that part of the story. So I just didn't put it in. But the point is to make a programming for this stuff so that I can program in whatever pieces I want to simulate and craft out whatever little RPG stories that I want out of it. And then run the simulations, of course, to see how the different characters fare. So I'd like to be able to get to the point where the parties can like travel from town to town, and that the simulation can have like a map that they are bouncing around in, and see what paths tend to lead to success, and so on and so on. I like to be able to push it pretty far. But it's a lot of ambition, and we'll see how far I actually get. Right now, I'm still just stuck on being able to extend the combat system to include this new idea of a chase sequence and manage the flow of all of it elegantly enough that it doesn't become the whole game, the whole simulation. But anyway, I think I'm going to wrap that up here today. Um, I think that there's something to this rule idea and the state idea. It makes some sense that the parties are each in a state, and that state carries information about what they know and can do and are doing. And then the rule tells us what happens when two parties in that state are meeting. I also want to have rules for parties by themselves, solitary decisions, and I don't have that yet worked out in this. And I also don't have anything for these exits, so like I'm not even done setting this up, but like I have to figure out again what the combat context is going to mean and stuff. I might be about to tear things up and then reset a bunch of stuff, because like I sort of started building a state system with a single state for the whole game, and now I'm thinking that's an issue. So yeah, I think I'll probably keep working at this all week this week, and maybe for the next few weeks, just because again I do want to get to the point where I can work on the Mr. Fourth base layer and get that updated for everyone who wants to rely on the most recent version. And in order to get there, I think I need to get there through the RPG Simulator. It's the project I have which is closest to having a DLL, so I'm going to just focus on this, but keep doing it right, I think. So I'll come back tomorrow with more of this, and probably, hopefully by the end of this week or the start of next week, I'll see if I can have an idea for how this whole state system is going to work out. All right, anyways, later everybody. See you around the internet.